Okay, welcome to Con Summit 2021. We are super excited to talk today with you about some interesting things. And my name is Victor Gamov. I'm a developer advocate here at Con. And today with me, I do have my friend Ricardo Ferreira as my co-presenter here. And we're doing the virtual fist bump.
Fist bump.
Yeah, we'll try this. We're going to be talking about service mesh and some of the observability and extension of this observability through ML. The session works smarter, not harder. In the world of that we live right now, for the past couple of years, give or take, right, Ricardo? I think we were talking about microservices a lot. We're talking about microservices development of using different frameworks, how you can deploy this, how you can communicate this. But essentially, we're always forgetting about the things that might be surround this microservice. Once you're done with your implementation, there's a lot of things that you need to be doing on the day two. That's what we call the day two responsibilities. Like everything starts as easy, like when you have one service, everything is nice and easy. You know what the framework to choose. You're doing great. You put a lot of stuff there. You deploy this. You're happy. So the next thing is that you're starting adding more features. When we communicate to those microservices through different APIs, it can be HTTP, it can be gRPC, it can be Kafka or whatever. What have you? What like you? Very soon you are so excited and you're going into your microservices becoming really big, really powerful. You do a lot of things there. But all of a sudden, not all of a sudden, over the time, these things are becoming your microservices deployment, your deployments becoming a very dark place. So dark that you basically, if you didn't put the proper tools around observing your services and looking inside what is going on, you very soon will find yourself with a bunch of like dead code in places, or maybe dead services, or some broken services that don't work as the way you intended to. And as a character from the It's Always Sunny in Philadelphia, a character played by Charlie Day, you would try to find who's the Pepe Silva. You would try to find where's the root cause of certain problems and things like that.
I would say stop just collecting data, right? Because people used to say that, observability is all about the three pillars that comprises traces, metrics, and log. But I think in the end of the day, each one of them has their value, of course. Like metrics are good for giving you an insight about what's going on. Traces can point out where the problem is, and logs actually explain what the problem are.
Yeah.
But in the end of the day, we need a consolidated view of everything. So no longer think about pillars, right? Individual and silos pillars, but actually pipes where all of them kind of work as streams that will be stored in a single location, where in the single location we can have much more like analysis and insights. And because all of them are going to be correlated, now you can have a much more like precise perception about what's going on, right? So
exactly. So we're gonna starting with we call it metrics, maybe not 100% correct thing here, because we're gonna showing some how to enable all the possible observability pillars, right? So we're gonna start with logs. We're gonna go to metrics, and after that we're also gonna talk about traces. And for this, let me quickly switch to my screen, and I'll show you this quick manifest. So when I enable this service mesh in my cluster, I will be able to do multiple things. When I define a spec for my service mesh, I can enable this logging section. With the logging section, I can pick up a few different solutions. In this particular case, we're going to be using Logstash because, and Ricardo will explain this in the future, with Logstash we can specify a format, how to output those traces. So there's a different approaches how you can what we call it like a prepare or like a massage the data before it will be consumed by the system. However, we want to prepare it in a format that it will be much easier to digest and not need to require any other work. So, and this thing will be, once I apply this, once I apply this spec, those logs will be automatically flow from all your microservices, from all your services that you have inside this mesh, which is very neat and very nice to have. And so once we're doing this, now we're moving into Elastic, and this is where the step that we did before step of formatting data in the right format will will be taken into account. This is where Ricardo thinks.
Let's now discuss about, Victor just showed how can you enable this telemetry data, which is metrics in this case, and expose it in your Kuma service mesh. Now, how can we bring this data in to Elastic, right? But the first question that you should ask yourself is why Elastic, right? So Elastic has this machine learning capabilities built in that you can leverage to do the analysis for you, and this is exactly what we're trying to accomplish here. So think about the objective of this, let's call ingestion layer, to be ultimately get the data into Elastic, right? So that's your objective. How can you do this? Well, luckily we have options, and I like to bring up this slide where it shows the menu of in and out, because Victor and I, we are in much love of in and out. So Victor,
since the Conch Summit, since the Conch Summit is even though it's virtual, but we're trying to bring some of the West Coast dynamic to you, and I hope you're enjoying all this like a cool break so far. In and out is our favorite place to go, and there's a different the menu of in and out is rather simple. However, it also has some kind of secret, but it's not a very secret menu for more advanced users. So that's why here we want to present you menu of the things, how you can do things in observability world. So that's why this analogy here. Plus, it's always good to get the few Flying Dutchmans.
Exactly. So it's all good to have options. So the first option I would like to discuss is Metricbeat. Metricbeat is a component of the Elastic Stack, and basically what Metricbeat does is to scrap periodically the Prometheus endpoint that has been at this point enabled by the Kuma service mesh, and then Metricbeat can read the data and store into Elastic. But the most important part is that it just only stores, but also formats the data into a format that will enable data analysis, right? So it's not just a huge string that will be stored. So there will be layouts, there will be columns, data types, everything we need to actually start working with the data. Metricbeat is interesting because you can deploy it as bare metal, Kubernetes, Docker, and you can quickly spin up one instance. You definitely should explore Metricbeat as a sidecar for your microservices. And the most important thing that a Metricbeat also does is to provide options for you to handle the load, because if the sidecar...
All right, so this is Metricbeat. Okay, we got this Metricbeat. Are there other options available for our listeners, watchers, and users?
Yes, there is another one, which is the collector from the OpenTelemetry project. So what the collector does is pretty much the same thing that Metricbeat does, which is scrapping the Prometheus endpoint exposed by Kuma Service Mesh. The only difference is that the collector will store this data into Elastic into this format called OTLP, which is the native protocol that OpenTelemetry supports, and then the Elastic is compatible with this protocol, right? So just like Metricbeat, it can be deployed as a sidecar, whether if it's Kubernetes, Docker, or bare metal, and there's a bunch of options that you can tune in to actually keep up with the load, so it's highly configurable. There are actually is a very convenient option if you want to stay like, adopt an open standard, because in the end of the day, like this is what Kuma Service Mesh is. This is open standard, basic on envoy proxy. So the combination with the collector and OpenTelemetry and Kuma, I think, is a good deal.
So I do have a question here. So like I've been in this world of the distributed systems and in general the systems that communicate to each other for quite some time. And there's usually two patterns of how you can get something from other systems. Either the system will push you with some data or you will be pulled this information. So as far as I understand from the things that you just explained, there is a little bit different in the patterns how the OpenTelemetry collector and Metricbeat operate with the Prometheus at this point.
Correct. Yes. So both of them can do the polling part, just like you've described it, but only Metricbeat is actually capable of doing pushing, right? So what I mean by pushing, it all has to do with this feature called remote write, where the Metricbeat can expose an endpoint, and then you can configure your deployment on Kuma Service Mesh to actually point to that endpoint, and then now service mesh will actually push all those metrics down to that system. So that's for those of you that know the difference between polling and pushing. You know that pushing is a little bit more efficient in terms of data transmissions and doesn't consume a lot of hardware from your machine, so it's preferable, right? But that's a significant difference between the collector and Metricbeat.